time, yeah, in our syllabus, okay, they have removed X-ray crystallography, yeah, so you do not need to know about that. So this one erase, no need. Okay, so only focus on NMR spectroscopy, yeah, and this one no need to do. Okay, and then okay, this also no need to do. Okay, the rest we can do. Now, if you look at this, okay, they are asking NMR spectroscopy can be both used to examine the structure of organic compounds. Okay, NMR is very useful in examining hydrogen atoms. So they are talking about proton NMR. Yeah. So explain why NMR spectroscopy can detect hydrogen atoms in molecules. Now, when you want to detect hydrogen atoms in molecules, yeah, NMR, how it works, because hydrogen, they have their own spin. Okay, hydrogen atom, okay, hydrogen atom spin and has, okay, its own magnetic field. Okay, that this magnetic field, okay, if the magnetic field is opposing the external magnetic field. Okay, magnetic field. Okay, you are going to have, okay, different energy gap. Okay, energy gap will arise. Okay, will arise, and okay, NMR spectrometry can be used. Okay, so don't worry, I'm actually writing a lot. Okay, but in the marking key, they just focus on spin. The moment you have the word spin, yeah, they give you 1 mark. Okay, so it means you need to know about, okay, to identify they have their own spin. Yeah. Now, the molecular formula of amino acid is going to be given such like this. Okay, so okay, later if we have if we can continue, if it is related, then we see. Yeah. Now the NMR spectrum below, yeah, was obtained from an organic liquid P. So this is different. Yeah. So they say it is obtained from organic liquid P, which contains 5 carbon atoms per molecule. Yeah. So there are 5 carbon atoms. Okay. And then, okay, if you look at the number of here, the 9, 1, and 2. Okay, this number 912 explains about the number of hydrogen that you have. And I know that there are 3 different environments in this particular molecule. And total number of proton, you see how many protons are present in one molecule of P. You don't need to worry so much. Okay, no need to think so much. This is 9, this is 1, this is 2. So 9 plus 2 plus 1 is going to be 12. Number of proton is 12. Okay, so explain your answer. Okay, so your answer will be they are 9 hydrogen in one environment. Okay, and then you talk about, okay, you keep on copying this. Okay, 9 hydrogen in one environment. There is going to be 1 hydrogen in one environment. Okay, and then you have, okay, another 2 hydrogen in another environment. So if you want, okay, in total, then they have, okay, total is going to be 9 plus 2 plus 1 equals to 12. That's it. Okay, that is how you explain. Okay, this is how you get the number of protons. Yeah, number of proton. So it's similar if you are thinking about the CH3, CH2, OH. Okay, last time, okay, if I want to get the data, I will have CH3, 3H, and then CH2H, okay, for CH2, and then 1 for H like this. If I add this, 3 plus 2 is 5, 5 plus 1 is 6. If I count, this is 1, 2, 3, 4, 5, 6. Yeah. So that is actually why, okay, we have that. Yeah. So this one, if you are confused with that, okay, so you just need to add them. Yeah. Now, if you continue, okay, when a little D2O, yeah, this is going to be heavy water, yeah, is added to P, the absorption at 2.0 disappears. Yeah, they say this absorption disappears. Yeah. So they're asking, okay, explain what this tells you about the group responsible for the absorption. Yeah, if you have, okay, something disappear when you put the D2O, okay, the group responsible must be the hydrogen attached to O or hydrogen attached to nitrogen. Okay, so what happens, okay, rapid exchange, okay, happens between hydrogen in the molecule and hydrogen in water. Okay, in D2O, okay, the hydrogen, two hydrogen, okay, is exchanged with OH or NH bond, and NMR spectrum will not be detected because it's even number. Okay, we don't want it to be even. Yeah, so we want it to be odd. Okay, we want odd. Okay, so it's going to be, okay, we don't want it to be even number. Yeah, so what does the absorption 0.9 tells you about the adjacent carbon atom? Now they're talking about adjacent. Yeah, so if they're talking about adjacent, it means this is going to be high resolution. Yeah, high resolution NMR. And if you look at this 0.9, there is only a single peak. If there is only single peak, there is no splitting. Okay, it means that there is no adjacent. It means the carbon adjacent to it, okay, do not have any hydrogen. Yeah, so there is no neighboring hydrogen atoms in the adjacent carbon. Yeah, so you just need to tell no splitting. So no adjacent or no neighboring hydrogen atom in the adjacent carbon atom. Okay. Now, what groups are responsible for the absorption 0.9? Now, if you look at 0.9 and then if you have 9, okay, I think everyone should know, okay, if you have 9 hydrogen, there's only one possibility to get 9 hydrogen. The carbon is CH3, CH3, CH3. I think this is the only possibility. But if you're not sure, yeah, you can always double check, okay, CH3. So you just look at the data. Okay, so if you look at this data, okay, this is going to be, we have to look at, okay, this is the proton, yeah, proton. So CH3, okay, CH3, 0.9 to 1.7. So it matches, okay, it matches. So it is actually from CH3. Okay, you get the data and then you say, yeah, so what group responsible? Hydrogen from CH3. Okay, suggest a structure for P. Now you see, yeah, if you look at this molecule, okay, they ask 9, so I draw over here, and they say that the adjacent carbon, okay, adjacent carbon don't have hydrogen, so cannot have hydrogen. Don't go and put hydrogen there. Okay, cannot have. Yeah, so this one cannot. Okay, so you also know that there are 2 hydrogen environment over here. Okay, it means 2 having the same environment. So it means most likely 2 having the same environment is like this. Okay, and then this one, okay, every single time when you have this kind of CH2, if you look at it in the form of puzzle pieces, they always come in the middle. They are interconnecting. They cannot come at the side. They're always in the middle. Because why? They have to join with this. They have to join with that. Yeah, they always come in the middle. So most likely I put the carbon here, hydrogen here, hydrogen over here. Now you can ask me, yeah, if I put like this, does it mean that now the neighboring hydrogen, there's two and then there's splitting? The answer is no, because the way it looks like this, it is a bit confusing. But if you look at it in detail, you see, this is the hydrogen, this is the carbon, adjacent carbon is this one. The adjacent carbon don't have any hydrogen directly attached to it. Okay, so the carbon that is attached to the hydrogen over here, they are like neighbor to neighbor. Okay, they are far away. Okay, so don't actually think that they are going to be the adjacent. They are not the adjacent. Okay, there is no splitting over there. And then if you look at these two also, okay, there is no splitting. Why? You see, the carbon attached to here, there's no direct hydrogen. Okay, that's why it's single peak. And then this one must contain OH and NH. Now, if I put NH, something wrong. All the nitrogen must have 3 bonds. So I need to put NH2. But they say it's 1. They didn't say it's 2. Okay, so I cannot put NH2. Okay, I cannot put NH2 because NH2, okay, there are 2 hydrogen having that environment. Okay, I cannot use NH2. The only thing that I can put is OH. Okay, why? 1 environment, and it corresponds to that. Yeah, so you have, okay, a situation like this, and this is the molecule that they are looking for. Okay, so if I want to suggest a structure, the structure is CH3, C, CH3, CH3, CH, H, and then OH. This is the structure. Follow what they want. They just say suggest a structure. Sometimes they say draw the displayed formula, draw the structural formula, okay, draw the skeletal formula. They can just come up with their own version. Yeah, but this is the idea. If they didn't specify any way that you draw, yeah, it's okay. Okay, this is going to be how you solve this particular question. Okay, so let's actually let's see whether is it okay. Catherine, okay, can understand? Audrey, okay?
Yes, sir.
Okay, so let's move on. Okay, so here, yeah, this is the one that I will teach you tomorrow. Yeah, the combination of mass spectroscopy and NMR spectroscopy. I told you they move it to your AS, but I just most of the questions that I see, they always have given two marks for mass spectroscopy. So I think I need to teach you. Yeah, but today is not the time to teach. Okay, tomorrow I'll teach you. So they say that, yeah, they will have this M and M plus 1 peak at a certain ratio and so on. Okay, but forget about it. Okay, just take this information. Okay, they have 3 carbon atoms. Yeah, so the answer for that is 3 carbon atoms. I will use that 3 carbon atoms to continue with this. Yeah, so there are 3 carbon atoms. The information that you have. Okay, G contains 3 carbon. Okay, just remember this. G contains 3 carbon. And then you have this NMR spectrum, okay, of G. And if you look over here, okay, Jackson, is this low resolution or high resolution?
Hi, sir.
Is this low resolution NMR or high resolution NMR?
Hi.
Yes. Why?
We can see like the splits.
Yes, okay, because we can see splitting. Yeah, we can see splitting. So you see here, okay, they say that, okay, using the data booklet, later I have the information all in this worksheet, and your knowledge on NMR spectroscopy, identify the type of proton responsible for each of the 3 absorption. Yeah, so they say that this is going to be 1.1, okay, this is 2.2, and this is going to be 11.8. Okay, so let's see whether other information is given. Okay, I think only that. Yeah, so here, okay, they are asking the type of proton. Let's actually look at let's bring this directly there. Okay, let's look at the let's look, okay, at the type of proton. Okay, so if you look at here, okay, we are looking into 1.1. Okay, so let's actually look at 1.1. The one that actually will come under 1.1. Okay, I think most likely the here, this one. Okay, and then 1.1. Okay, maybe here. Okay, 1.1. What else? Okay, maybe here, alcohol. Okay, so here, if I look at it, okay, most likely I'll just put first CH3, okay, or CH2, CH. It can be alcohol. It can be R and H. I'll put down first. Yeah. Then 2.2. When I look at 2.2, I think I have the alkyl next to CO. Okay, I think 2.2 alkyl next to CO. And here possible, here also possible. I think there are a lot of possibilities. Yeah. So let's actually take the obvious one first. Yeah. And then 11.8. 11.8. Okay, if I look at 11.8, let's see where 11.8 cannot be this, cannot be this, cannot, maybe here, maybe here. So this one or this one. Okay, it can be carboxylic acid or MR. Okay, OH and NH. I'll just put OH or NH in carboxylic acid or amide. Okay, now I copy back this. I will just go back to the question. Okay, now use the data and identify the type of proton responsible. Okay, when I see here, okay, I do see one line. Okay, if I see one line, okay, you know that it must be NH or OH. Okay, so you see here it can be OH or NH, carboxylic acid or amide. Okay, so this one, okay, I can use two answers. Okay, I don't think so there is enough information here. So identify the type of proton responsible for this. Okay, you can say O type of proton, okay, H attached to O or H attached to N. Okay, this one in carboxylic acid or this one in amide. Okay, you can actually give both. Okay, later we'll check the answer key. Okay, and then for 2.2, okay, for 2.2, okay, I do see, okay, that they have, okay, total of splitting 4, so they have 3 hydrogen at the there is 3 hydrogen, okay, in the neighboring. Okay, so that is going to be 4. Okay, but okay, they ask you to identify only. Okay, I will just follow what I have. Okay, so this one, the type of proton next, maybe alkyl group next to CO. Yeah, alkyl group next to C double bond O. Okay, type of proton over here. Okay, this one I will not select. Okay, because it's not single peak. Okay, it's not single peak. So here, okay, I think I'll just say alkyl group. Okay, so if I compare with the marking key, 1128 already. Okay, let me compare the marking key. All this marking key and so on, you already have, yeah? So please This is what? One. So this one, okay, the answer given is going to be RCH3, okay, which is correct. Okay, RCH3. And this one, okay, alkyl group next to CO, okay, the answer given is going to be RCOCH3, correct? Okay. And then this one, okay, only this one, I think they say they included, okay, they just put RCOOH and RCONH, yeah, which is correct. Okay, we already identified. Okay, so if you give your answer like this, okay, it's going to be correct. Okay, but just the way that we write our answer, we just need to work on that. Okay, that is how to apply first. Yeah, so all these are correct. Okay, now the addition of D2O, okay, causes one of these absorptions to disappear. Yeah, explain why this happened and state the absorption that is affected. The absorption that will disappear is this one. The one at 11.8 will disappear. Why? Okay, because I already mentioned to you, okay, rapid exchange, okay, of the hydrogen, okay, atoms, okay, between the D2O and the hydrogen from the carboxylic acid or amide, okay, they are going to give you the hydrogen to have even number. Yeah, the even number will not be able to detect to be detected in the NMR spectrum. Yeah, so that is going to be the answer for that. Okay, and then you draw the structural formula of G. Okay, because I think now, okay, using all this information, we know it's going to be having three carbon only. Yeah, using three carbon only, we can actually find out some details. Okay, you see, if you have three carbon, it means there are three carbons, and I know there is going to be OH or NH. Okay, and then there is also going to be C double bond O. Okay, so most probably if I put like this, O and then OH. Okay, and then there is alkyl group. So this was CH3. Okay, alkyl group next to CO, this one. So I think most probably this will be the answer. Okay, so here if I look at the answer, CH3, CH2, COOH. Yeah, you see, this is how you come up with the answer. Okay, so using all this information that you have, okay, you come up with the answer. Okay, you draw the structural formula. Structural formula is CH3, CH2, COOH. Okay, and then several structural isomer of G exists. Draw isomer and so on. Okay, so this one you can do. Yeah, so we will continue next lesson. Okay, draw. Okay, and then use all this information. Okay, just roughly I want you to understand. Okay, we can solve the questions, okay, using all the information that we have learned. Yeah, so Josh, is it okay? Is it your line?